And welcome back to another video in the series. So, last video we went over authentication, authorization, implementation techniques. I dare you to say that fast 5 times. But now we're going to go over authentication and authorization solution, right? So, in our first exercise, we're going to get over or go through authentication management. Rather, we're going to do a few things. So, what I did was actually, you know what? I can talk about it to a certain extent, I guess. So before a user is, let's say, granted access, right, to a local network resource or web, right, or web application on the internet, right, it's necessary to authenticate the user naturally, right, for security purposes. Authentication can be performed using a simple username and password, of course, but it also could be combined with other authentication methods, which we went over in our last video with MFA, right? So like a smart card, which is what I use, or a security key, right? And you can use password keys, and you can also use a password vault, which is going to get into our first task that we're going to actually implement. So what I did was, just to tell you a few things I did prior to started recording, I went to a website called Dashlane, and I'll show it to you in just a moment. And I just set up a few things, right? Just to showcase using a password vault, right? So I logged in. Actually, I'll show a bit here. All right, logged in the password manager website, and I also installed the extension as well, as you can see on the browser, right? And I'm also entering the email. Let's see, email I created, of course, for for this exercise. Sorry about the password. All right, so there it is. Nothing to the app, I guess. All right, so I'm just gonna add my, let's see, create an account. Add your first login. Let's say Microsoft. Okay. Then, right. So, all right, perfect. My password. Um, the save. Yep, perfect. So I saved my first login. Actually, I'm gonna see it in Dashlane. Hopefully, it'll open up another tab. All right, perfect. So we actually saved our first login, right? So we can actually see it in the window. We can obviously add a few more view history of past logins as well. And I'm actually going to, let's see, take a look at the dashboard if I can. See here. It's not. I guess this may be considered the dashboard, right? But nonetheless, the password for the specific email provider that I have, I created for this lab in particular, usually a lot of the times the recommendation for the password would be given, right? And so the web extension that you would have in your browser, if you choose to add so, right, it'll safely store the password and protect the account, or best protect the account. Now, different providers' credentials can be stored in this matter to protect the integrity of the account, of course. And which goes into a multitude of other things, right, like hardware security modules, which security devices use for safeguarding, managing digital keys, right, hash function or HSM function, which could be encryption keys management, encryption, key exchange, and cryptographic functions, and TPMs, trusted platform modules, things of that nature, right? Microsoft also provides a method to check to see if you have a TPM chip on your motherboard, So you just need to simply run the TPM MSC module. If you're using a virtual machine like this one, you may not see it. But actually, let's see. I'm still going to get into the concept of running it. Let's see. TPM. So now I get the trusted platform module console, right? So it's a virtual machine, so it doesn't have TPM, unfortunately. I wish I could get a bit more into it as far as practical application for it versus just talking about it. That could be pretty boring. But nonetheless, we could still get into a few other things, such as managing file permissions and ownership, right? We can do that actually over in Kali here. Let me go ahead and log in. Right, so you can actually use file permissions to enable users to access a file or directory for selective operations, right? For example, some users may only have read-only rights. Some may have write and read, right? And some may have them all. Usually the administrator for the file and or folder would have, read, write, and executable. All right, but nonetheless, we're going to open up the terminal as usual. So we're going to list the directories with permissions. So I have 0, so it should have a bit more than that. So usually a list of permissions, right? At least as far as what I was looking for, a list of permissions on directories that you would be listed with. And it's denoted usually with D as the first character, right? As far as the directory. So there's 3 types of group for directories. So there's an I for the symbolic link and the regular file, and permissions can be read, written, or executed, like as I mentioned, RW or X. Right. So I'm actually going to clear this out. I didn't get the result I desired, but I did get a result. I didn't get an error. So now I'm just creating a new text file, right? So I'm going to look again. Right. So it's a 0, but at least I have something as far as that text file, right? So because I may own the file, right, as the user. So I'm just gonna. I've done some of this before, right, in other videos. Let's see, text file. Right, so I just added the execute to execute bit to the file. So I'm just gonna clear this out, and I'm going to view the permissions for that file as well. Let's see. Did I type? Yeah. Yeah. Okay. Perfect. So now we can see the execute bit has been added. Right. So now I'm just going to add the write and execute permissions for others. So actually I can do that there. So, right, execute and for others. There we go. Then we can actually clear it out and take a look at the list again. And now we can see that others, the execute bit for others is now added to the file. So now I'm just going to remove the read bit from the group. So we can do, let's see, and you'll see a theme in what I'm about to do now. Yeah. So as you can see, before, if you don't catch it, it's usually it was a plus sign before as far as me adding permissions. Now there's a subtract sign for me removing permissions. So we can actually check it again. And as we can see, it has been removed, right? Now I'm just going to add the read, write, and execute permissions to everyone. So let's go back here. GL WX. Perfect. And then, of course, we can look at everything. And there we go. So now everyone has the permission for rewrite and execute. So now we're just going to change the permission with numbers, right? You have symbolic and octal, right? You have symbolic, which is rewrite and execute. You have octal, which is 431, 421. I'm sorry, and standard permission for files is 666 or negative RW, negative RW, negative RW. And let's actually take a look at doing that. So I'm going to clear this out. text file again. Right. So now we're just going to verify the permissions have been changed. So actually, let me see. Ah, that only too fast. Perfect. All right, so now I'm just gonna add the owner's execute a bit. So this one, perfect. So now I'm just gonna add write and execute those bits for others. So we can do first one. All right, and of course second. All right, now we can see those have been added, so we can actually clear this out. Now we're going to do 607 instead. And then perfect. All right, so now again, verify, press to verify. All right, perfect. So now I'm just going to keep the permissions, well, the window open for what we're going to get into next. That's using command to check permissions, which is kind of what we've been doing so far, right? Using the chmod, chown, and the chgrp, right? Which is sort of what we've been using, but now a little bit slightly more in depth, right? So various commands can be used for managing file permission and ownership, right? So the chmod that I've been using here, right? Here is pretty much just for uh, managing file permissions, and the other one that I mentioned, chown, is used for changing ownership. And so, I mean, it just, it's exactly what the command sounds like. The chgrp for changing groups, right? So let's actually clear this out. Like things looking being convoluted. I'm gonna create a third version of our text file. So so now it has been created. So now we're just going to use the chmod command. It's been covered in detail, right, in the previous exercise that we did. So this task that we're going to do now is just going to focus on the other two that I mentioned. So let's actually clear this out. Now we're going to create a user. So let's do user add, right? So even though this user I just created is going to be in a locked state, but we can still assign the ownership, right? So change ownership to Matt for this file, right? Perfect. And then we can also, of course, double check. All right, and we see Matt also has ownership, right? So now we can change the group to Matt as well. Let's see. Perfect. And then of course we're gonna double check. All right, so I'm actually gonna clear this out. I'll clear it out with some clean. All right, so we can also change the group using the own command. However, the syntax is just slightly different than chgrp. So to change the group to the root, we can actually do, let's see. Right, perfect. And of course, we're gonna check. Perfect. So now Matt is the owner, not only the owner of the file, but the group is the root as well. So now we can actually take a look at setting access modes, right? So permissions in Linux have two special access modes. They have SUID, which is the set user ID, then they have the SGID, which is set group ID. So when enabling access modes, right, set on an application, it runs in a user mode of the owner, right, rather than the user who initially started it. So similarly with the SGID access, with that mode set, the program will run as if the initiating user belonged to the so, all right, belong to the files group rather than to his group. Right. So either or both access modes may be set. So we're actually going to take a look at listing the SUID access mode on particular command. So let's take a look here. I've actually used this before. All right, July 16th, 2019. That was a good time, right, for the pandemic and everything. So, but we notice that the user permissions right here do not contain the execute permission. Rather, there's an S, right? So, let's see. Yeah, we see it here. There's an S, right? And which indicates the SUID, set user ID, right? And executable bits are defined for this executable. So when a user needs to run a password, it executes as if the root user had executed. So we can actually set the SUID and the SPID bit, and this is done by adding the S. So usually the SUID has the value of 4, and SPID usually has the value of 2. So to assign it, just going to change ownership, group, and right. Oh, that has to do something else first. Okay, good. Is it not? Usually something I did. Is it not change access? You know what? Let's see. Okay, so let's actually clear that out. And now just going to view the assigned SDID with going to be a bit of a different one, at least something added. Right, so we see Matt again, the root. So actually, let's fill this out. Right, so let's actually create a new one. Right, come up with that. What do you mean? Okay, let's actually close this out then. Good line. So let's take a look at something else because huh, all right. So I was able to fix that. I have to make the directory for PLAB in order for me to create the file slash folder really of for the touch PLAB /test .text. So we got that taken care of. So let's actually go ahead and okay, shouldn't have done that. Perfect. There we go. We're getting somewhere. All right, perfect. So change the perfect. So we just removed the right permissions, right? So I'm just gonna clear this out. Everything so looks clean. So let's do B for PLAB. Perfect. So we just assigned a sticky bit, right? So let's split this out. And just going to print the symbolic and octal values. Let's see. believe that looks about right. There it is. All right. So we printed the symbolic and octal value successfully. All right. So now we're just going to work with immutable files. So even though access modes and permissions can provide great control over files, right? Directories, uh, prevent, they cannot prevent the accidental deletion of files by the root user, at least. But you can set immutable attributes on files and directories. So when this attribute is set, even a root user can't delete these files and folders. So let's actually fill this out. Then we're going to set the immutable attribute on the PLAB text file. So let's do. All right, perfect. So we've done that. So now we're just going to verify if the immutable attribute is set to the text file. So uh, just okay. I believe that's right. Yep. All right, perfect. So we're good. Everything looks good so far. All right. So now I'm just going to attempt to delete the text file. Did not work. Yep, operation not permitted. That's what we want to see, right? So now I'm going to remove the immutable attributes, and we do it pretty similar to how we did the other command. Perfect. So now we're going to, of course, test that out. We're just go. Perfect. So now we see that the attribute is no longer present. All right. So now I'm going to attempt to remove the text file now. So, perfect. So now I can notice, well, we can notice that the file is now deleted and no error is displayed, which means that we are officially successful. So this also means that this is the end of the video for authentication and authorization solutions, right? We're all about solutions. Now, just a brief recap of what we went over. We went over authentication management, authentication, access control schemes, and managing file permissions and ownership on a Linux system, right? Going over password vault, password keys, immutable files, set access modes, all of the good fun stuff, right? When it comes to solutions for authentication and authorization. Now, in our next video, we're going to get into even more fun stuff, implementing a public key infrastructure, and I'll see you there.